Hello, everyone. This is the lecture for section 5.1 and 5.2 of Math 210S, angles and the unit circle. So for this section, we're going to take a step back away from the calculus, and we're going to do some trig. We're going to start getting our feet wet a little bit into some of the more advanced geometric things that we need, and some definitions from trigonometry that we're going to definitely need in order to continue our studies in calculus, okay? What this section is going to do is exactly what it states up top. We're going to just study up on our angles and cover what's called the unit circle, okay? All right, so the first thing I got to define when we have to do, what we need in terms of trigonometry, right, is the basic, right? The absolute basic. What the heck is an angle? Okay. And an angle is basically something that does this right here. Okay. Basically two rays, they start at one particular spot, but then go in different directions, right? They may go in they may go in the same direction, right? And what we're looking at is this angle right here. Okay. That is what we call an angle. Okay. And this angle right here is defined as angle DEF. So if you guys, hopefully you guys remember from geometry in high school, right? The E is supposed to be that middle letter, whatever that is, right? That is going to be sort of like that's supposed to be our vertex, right? Okay. Another way that we denote it is sometimes if you take a look at a textbook, there we go. Yeah. Okay. In geometry, this is how we would denote them, okay? Once we start moving into trigonometry, you're gonna see one of these 1, 2, 3, 4, 5 Greek letters to define an angle. Okay. The first one that you'll see is this one. This is actually theta. Okay. The next one is phi or psi. Okay. And then these should look pretty familiar. This is alpha, beta, and this is gamma. Okay. On a regular basis, when we study trig, right, the thing that we use the most for angles are the Greek letters. Okay, so if you don't know them, that's okay. In our studies, we'll pick them up. Okay, but just know that usually, right, when you see Greek letters, we're referring to angles. All right. Let's get some of the nomenclature down. Things that we need to do. How do I say this? Things that we need to get comfortable with when we're writing down angles. Okay. When we usually write down an angle, we want to do it in this thing called the standard position. Okay. The standard position for an angle, right, is when the vertex is at the origin, right, and its initial side is along the x-axis. So something like this right here on the right-hand side. Okay, so if you take a look, our angle is actually this. It's this little strip going that way, and then this little strip going that way. Okay, this is the angle that we're going to be studying. Okay, all right. So to start, right, something that I need to define is going positive angles and negative angles. So if you go this way, so if you start here and go in this direction, so if you go, what is that, counterclockwise, right? That is what we call a positive direction. Okay. If you go the other direction, so if you start here and go, this way, right, this is considered the negative direction. Okay. Whew. Let me do some examples of what I'm talking about. Okay. So in the next example, I just want to draw some of these angles out. That's it. Okay. So for the first one, 90 degrees. I'm going to draw my X and Y. I know this might seem like a review for some of you, and that's fine. Okay. So suppose we have an X and the Y. Let's say I wanted to draw 90 degrees. Okay. To do that, I'm going to switch this to my purple pen. because I like using purple for these. For 90 degrees, I'm going to start it. Let me do the flamboyant. There we go. I'm going to start, my initial side's got to be right here. This has got to be my initial side, right? But for 90 degrees, I want to make this go straight up. Hopefully you guys know what 90 degrees are at least, right? So this is what would be 90 degrees. Okay? Okay. And I went this way. I should put that down. I went this way. You guys see how I went in the positive direction, right? Okay. Next one down. 180. So I'm going to still, I'm going to still slap down my X and Y. X-axis, Y-axis, right? Okay. My initial side is still going to be here, right? But now I want to do 180 degrees, right? That is equivalent to going all the way this way. Bam. So what I did is this. I started here, right? And I went all the way around this way. This would be 180 degrees. Okay. Next one. Same idea. Let me actually draw my X and Y. Nice. So there we go. X, Y. My initial side is still here. Okay. But in this case, I need to go down to here. And there's a direction I got to go, right? This is a positive 270. So I got to go 90 plus another 90, that's 180, plus another 90, that's 270. So this whole angle from here all the way around to here, that is 270 degrees. Okay? Okay, let's do next one. X and Y. I start my initial side. That's still going to be there, right? But now I need to do 360 degrees. So that's 90 plus another 90 plus another 90 plus another 90 all the way around. That is going to be 360 degrees. Okay. Now notice all of these are positive angles, right? And notice what direction I went. I went in the positive direction. I went counterclockwise, right? Everything changes, right? That direction changes when we have negative angles. Okay. Okay, so let me do the first one. Negative 90 degrees. So this time, everything starts out the same. So there's an X, there's a Y. Here's my initial side, right? But now I want to go negative 90 degrees, right? So that means I get to end up down this way. Okay? And to do that, I start here and I go that way. You guys notice that I'm going clockwise this time, right? Since I'm going clockwise, that's the negative direction. And I went 90 degrees in the negative 90 degrees. Boom. Cool? Okay. This one. Okay, same idea. Start here. There's my initial side. Okay, but I need to go negative 180. So I need to go in the clockwise direction 180 degrees. My final is this right here. That is negative 180 degrees. Okay? My Y, that's my X. Like I said, everything starts off the same. Here's my initial side, right? But now I need to go negative 270. So this is negative 90, negative 180, negative 270 degrees. So my final angle is this one. Okay? And then the last one. So just keep in mind, right, that we can have negative angles. We can have negative directions for angles. Okay? Just keep in mind what direction you need to go. Okay? Here's my initial side. Bam. Okay. But now I need to go negative direction 360, right? So 1, 2, 3. That's negative 270. One more gives me my negative 360. So my angle is actually this. It's all the way around back to where we started. Okay. This right here would be the negative 360 degrees. Okay. Whew. We're getting there. We're getting there. All right. The idea behind a degree, right, is really a number, a set of numbers that have been, I don't want to say conjured up. They served a a purpose for the first couple thousand years when we studied math, right? But eventually, what mathematicians ended up figuring out was that we wanted to get something that so we can explain a circle, right? But it is self-contained, right, within the idea of a circle. That is the reason why we have this value pi. Okay, so pi is a mathematical constant that represents the ratio. So basically, the fraction between a circle circumference, right, divided by its diameter. Okay, or the other way that we sort of define it, right, is the half circle. So half of the circumference divided by the radius. Okay, and the way that we say this is this. So I've got a little drawing right here on the right. This distance right here, whoa, this distance right here, from that point to this point right here, this distance right here, okay, it is a radius r, okay? And what we're trying to find out is how many of these radii, how many radiuses, right, can we take and go around a circle? Does that make sense? Okay. And the answer to that, right, the number of radiuses to go around one circle is going to be 2 pi, which is 6.28 dot, 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 dot. Okay. So if you guys see each one of these segments, so from here, whoa, 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 whoa. Oh, it erased stuff. From here all the way over to here, that is one radius. Okay. From here all the way over to here, that's another radius. From here all the way over to here, that's another radius. Okay. If you do that all the way around a circle, 1, 2, 3, 4, 5, 6. So you can put 6 radii, right, all the way around a circle, and then you're going to have a nice little fractional piece. Okay, that little fractional piece is that 0.28 and change, but just a smidge below a third. Okay. By doing this, by defining pi as something that relates to a circle, right, we now encapsulate all of the knowledge we can figure out about a circle from a circle. Okay. Which makes our idea of radians obsolete, sort of. Okay. Now, in order for everybody to learn about circles, the thing that was done to begin with was we presented degrees first, right? But in actuality, now, whenever we do things with angles, right, we have to convert them to radians. Okay, the radians is what sort of relates the degrees back to a circle. Okay. Okay, so what I'm gonna have to cover now, right, is we all know what degrees are. Okay, but when we talk about math with a circle, right, all of our angle measurements are going to be given in radians. So we need to figure out how to convert between degrees and radians and back and forth. Okay, so what I want to do is, let me scroll down. Here's a circle. Okay, I'm going to first write down some of the important degrees first. Okay, and those are these. This one's 90. We know that this one is 180 degrees. We already did these, right? And then I'm talking about going in the positive direction. So we're going this way. Whoosh. Okay. Okay. So then 90, 180, we know that this bottom one is 270 degrees. And then if we go all the way back one more way around, right, this is also equal to 360 degrees. So 90 degrees, 180, 270, and then the last one all the way around is 360. Okay. Now let me add some more. Okay. And I'm going to add the halves. So I'm going to add this one, this one, this one, and this one. Okay. 90 degrees divided by 2 is 45 degrees. Okay. So then 2 times 45 degrees should be 90 degrees. We're good. If we add an additional 45 degrees, that makes this 135 degrees. And if we add another 45 degrees, 180. We're getting there. We're getting there, right? Okay. If I add another 45 degrees to this, that's going to be 225 degrees. There we are. Okay. And if we add another 45 degrees to this, that gets us our 270. So everything's still looking good. Okay. If I add another 45 to 270, I get 315. And another 45 degrees, 360. All right. We're getting there. Okay. The next couple I want to add are these three. Well, these two here, these two here, and these two here, and these two here. Okay. These slice each one of the quarters. So this one sliced that 1/4 in half, right? This one and this one slice this quarter into thirds. Okay. 90 divided by 3 is 30 degrees. If I add another 30, 60 degrees. If I add another 30, 90. So we're good. It's working out, right? Okay. Add another 30, 120 degrees. Add another 30, 150 degrees. Add another 30, 180. So everything's working out. It's falling into place, right? Okay. Let's keep going. 180. Add another 30, 210. Add another 30, 240. Add another 30, 270. All is right with the world. Nothing's going on yet, right? Last, add another 30, 300. Add another 30, 330 degrees. Add another 30, we're back at 360. So we went all the way around. Okay? Boom. All right. These are the most important of the unit circle angles, right, in degrees that we're going to be playing around with. Okay? Anything else, if you don't have any of these angles, right, you are more than welcome to use Desmos to find them if you need to. Okay? But I'm more concerned with converting from radians to degrees. Okay? And the idea behind radians to degrees is you multiply by the factor, basically, right? So if you have degrees and you want to turn it into radians, right? What you would want to do is multiply, right, by pi divided by 180, okay? And then the same thing, if you have radians and you want to go into degrees, Well, come on, there we go. You want to go into degrees, you do the flip. You multiply by 180 over pi. So let me grab a couple of these, okay? Let me grab 30 degrees, right? And I want to make this into radians, okay? So and that means I'm going to be doing this one. I'm going to be multiplying by pi divided by 180. So it's going to be, I'm going to write it out first of all. 30 degrees times pi over 180. I can grab anything I want, put it over 1. So I can do 30 over 1 times pi over 180. 30 pi over 180. And this reduces to, if you cancel out all the common factors on top and bottom, this reduces to pi over 6. So let me make this thinner now. Okay. There we go. So 30 degrees is equivalent to pi over 6 radians. Okay. Let me do 2 more. 45 degrees. Okay. I can do 45 over 1 times 180. Oh, sorry, pi over 180. Equivalent to 45 pi over 180. And if you reduce this, pi over 4. Okay? Same thing as pi over 4. Okay? 60 degrees. Okay? 60 over 1, pi over 180. 60 pi over 180 is equal to pi over 3. Let me write it the same way that I was writing the other ones. Come on. Okay. I'm going to go ahead and skip the work for 90 degrees, but I will give it to you. Pi over 2. Okay. I want everybody to take a look at this. 1, 2, 3, 4. Right? Okay. You guys remember, right, when we were doing this one, right? This one was 30 degrees. If I added another 30 degrees, I got 60 degrees, right? If I added another 60 degrees, I got 90 degrees, right? You guys remember that? Yeah? Okay. Turns out the same thing can happen when we use our radian measures, okay? So if I grab this one, right, that's pi over 6 in radians. If I add another pi over 6, I get pi over 3. If I add another pi over 6, I get pi over 2. Okay, this is going to require a little bit of work on the side in terms of common denominators and all that stuff, but it works out. It works out. Okay, so let me do, first of all, let me do the ones for 45 degrees. So if I grab this, right, that angle is pi over 4. If I add another pi over 4, that's 2 pi over 4, which is pi over 2. If I add another pi over 4, I'm going to write it over here, 3 pi over 4. If I add another one to that one, 4 pi over 4, and that reduces to pi. Okay? If I add it again, five pi over 4. Add it again, 6 pi over 4. Add it again, 7 pi over 4, right? And if I add it one more time, right, I get 8 pi over 4. This reduces to pi. You guys see the counting? Okay. The exact same thing can be done with the pi over 6s. Okay. And I'm going to do those. You know, I'm going to do them in hot pink. Okay. Pi over 6. Add another pi over 6. That's 2 pi over 6. Add another pi over 6. 3 pi over 6. Add another pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. And hopefully you guys see that the 6 pi over 6s, that reduces. So that's gone, and you get left with the pi. 7 pi over 6. 8 pi over 6. 9 pi over 6. Okay, and it turns out it reduces, right, to 6 pi over 4, and that reduces down to 3 pi over 2. Okay, next one, 10 pi over 6. 11 pi over 6, and then one more, 12 pi over 6. That reduces down to 2 pi. Okay, these, like I said, are the most important of all the unit circle angles, both in degrees and in radians, that we're going to be messing around with. Okay, anything else, you're going to need to go to Desmos to figure it out. Okay, but the conversion is real simple. It's basically this stuff. It's this. Damn. Okay, so the first thing I want to do for practice for everybody is to make sure that you guys can convert from certain angles to certain radians and back. So if I give you a radian angle, give me the degrees, and if I give you degrees, give me the radians. Got it? Okay, this is going to take a little bit of time. It's going to take some practice, so I want everybody to try these out. Okay, moving on. We are getting closer and closer to sine and cosine, the two basic trigonometric functions that we're going to need for our study of calculus that requires the trig portions. Okay. Before we move there, before we get there, I got to show you guys this. Pythagorean identity, or the Pythagorean theorem, sorry. Okay. It's the one that you sort of know and love from geometry. If you have 1, 2, 3 sides of a right triangle, right, then they've got to fit this equation right here. A squared plus B squared is equal to C squared. Okay. This only works for a right triangle. This only works for a right triangle. Okay. So if I want to find the missing length, if I want to find this length A that's right here, right, then I set it up just how you think, right? So it's going to be A squared plus 8 squared. That's got to be equal to 17 squared. Okay. A squared plus 64 is equal to 17 squared, which is something. I should have wrote that down, shouldn't I? Let me compute it real quick. 289. Okay, so then that means A squared is 289 minus 64. $225, and then the square root, so A is equal to the square root of 225, which is, where's my square root? 15. So what we did was we found this missing length. This missing length is 15. Okay? Okay. I want you guys to practice on this. Find the missing length, okay? Now we can get to it. Unit circle, okay? And in particular, what we're going to be picking up is the two basic trig functions, right? And the associated last one that's a combination of the two, okay? So all of trig is this. It is sine, cosine, and tangent, and the study of sine, cosine, and tangent, okay? So on your unit circle, right, we can provide angles. You guys see this angle right here? This angle is an angle T, okay? This angle right here is an angle T, okay? What we are trying to say, okay, for sine and cosine is that the cosine for a given angle T, right, is the, let me actually highlight it how I say it. The cosine is the x component, the horizontal component, right? And the vertical component, the one that goes up and down, right, is sine. Okay? So what we're saying is if I want to travel a certain amount of angle, right, that is insinuating that I am going to be going a specific amount in the horizontal direction and a specific amount in a vertical direction. That is the definition. That is the definition of sine and cosine. Okay, and the closest thing I can think of to sort of put this into your brains, right, is there's an old toy way back, maybe when you were 5 or 6 years old, right? Picture this: you go to Toys R Us, you go to Target, you go to the kids section, and there was a toy in there, and it was called an Etch-a-Sketch. It was a blank screen, right? And it had two little knobs, and these two little knobs controlled a little dot on a screen, and that dot on the screen either went up or down or left or right. One of the knobs took care of the up and down. The other knob took care of the left and right, right? Okay. Cosine is essentially the left and right knob because that's the horizontal, okay? Sine was the up and down knob that took care of the vertical, okay? That is the closest idea I can give you to an Etch-a-Sketch, to what sine and cosine are actually defined as, okay? But what we're doing is we're trying to find how much left and right or up and down we need to go given that we've traveled a specific angle. Okay? Okay. We're getting somewhere. We're getting somewhere, right? I'm going to erase everything except for my highlighting. There we go. Bam. Okay. Okay. So now that we know what sine and cosine are, there's one more function that we can relate. It's tangent, okay? So if we know that if we know that sine and cosine are the y and the x, the tangent is y divided by x, okay? On a random triangle, so let's say this one is now an R, right? We know that this is the X and this is the Y, right? Then we can also produce these definitions for sine and cosine. That if we're given a specific radius, right, on a circle, then the cosine is the Y divided by R. Sorry, whoa, that is an actual mistake. This is supposed to be X divided by R. And this is supposed to be y divided by r. Woo! Okay, we are looking at the ratio between the vertical component and the radius. Okay, all of this, if you take a look at a triangle, right? If this is our angle right here, this is our angle. We call this side. We call this our opposite, and we call this side way down here. We call this our adjacent. And that is where we get this thing. We get, hopefully you guys remember this from high school, SOHCAHTOA. Okay, and SOHCAHTOA is just an acronym just so we can remember what sine and cosine and tangent are actually defined to be. Okay, sine is equal to opposite, right, over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Okay? There we are. Now, these are the definitions of sine, cosine, and tangent. Okay? In practicality, this is what we really do with them. Okay? So suppose I have an angle. So you guys see how this angle right here is this, right? And this point right here is given by this coordinate right here. Yes? Okay. Then automatically what we can say is this, that the cosine of this angle t is the 1/2. That is the x portion. Okay? Whoa, not what I wanted to happen. And then the sine of my angle t, that is equal to the square root of 3 over 2. That's it. We have sine and cosine, right? Likewise, suppose we had this point over here on the right, that is given by this ordered pair right there, right? So cosine of t can also be negative root 2 over 2 for this angle, right? And then sine of t is the y component, positive root 2 over 2. So this is how we use sine and cosine and tangents. Well, sine and cosine in particular. Okay? Okay. The first of many Pythagorean, the first of many trigonometric identities is the one called the Pythagorean identity. It's this one. Okay? So, suppose you had any real number t, okay, that can be an angle, right? Then the cosine squared of the angle plus sine squared of that angle is always going to be equal to 1. Okay? Why is that true? Suppose I have my circle. And we know, for example, right, I can choose a point. That is going to be on a radius r. Whoa. That is going to be on a radius r, right? So here's my r. We know that there are two components, right? We get to this point by going an angle t, right? And we know that the x component, that's going to be cosine of t, okay? And the vertical component is sine of t, right? Okay, you guys see the triangle that's there? Here's the triangle. I'm gonna make it in green. There we go. You see that triangle right there? That triangle, whoa. Oh, I hate it when it zooms out like that. There we go. Huh. That triangle is a right triangle. Okay? We can hit it with Pythagorean theorem, right? So then sine of t, whatever that is, squared plus cosine of t, whatever that is, squared has to be equal to r. right? And r squared. And in this case, we're saying that it is equal to 1. So this is where we get sine squared of t plus cosine squared of t. That is all got to be equal to 1. Okay. I do have to bring up notation of use. Okay. There is a little bit of an ambiguity in which we write down trig stuff. Okay. Notation of use is this. If you have sine of t, right, and you have that squared there, that is equivalent to saying sine of t, whatever that is, grabbing that and squaring it. That is not the same as sine of t squared. So this is going to be interpreted as that, and those aren't the same thing. Okay, so when you are studying sine, cosines, and tangents, right, keep this in mind. Okay, and just so, and I know the class is fast, right? Use your parentheses. Use your parentheses wherever you think you need them. Okay? All right. All right. Now let me go ahead and cover how we use sine, cosine, tangent, right, to find the other measurements. Okay? Turns out, right, if we have one of the measurements, either sine or cosine, we can find the other ones. Okay? So for example, let's say cosine of t is in the fourth quadrant. Okay? We need to find sine of t. So fourth quadrant is this one. Okay. Cosine of some angle theta is the x divided by the radius, right? So we're saying that our triangle is this. Okay. Our radius is going to be 25. So we know that this is going to be 25. Our x portion is going to be 24. We need to find this, right? Okay. You guys see the Pythagorean theorem happening already? So we're going to call this A. So this is saying A squared plus 24 squared has to be equal to 25 squared. 25 squared. Come on, there you go. Okay. A squared plus, I should get my calculator out. 24 squared. Where's my square button? 576 has got to be equal to 625. A squared has got to be the 625 minus 576. 49. A is equal to the square root of 49, which is 7. So we found our missing side. It's equal to 7. But what we wanted to find was sine of t. And we're almost there. We know that sine of t, sine of our angle t, has got to be equal to the y portion divided by r. We now know what the y portion is. That's 7. And our radius from the very beginning is 25. Boom. Okay? Okay. I'm going to get you guys to practice a little bit. I know this is coming out of left field a little bit. Some of this might be review for everybody, and that's all right. I'm going to try these out during class, right? We're going to work on how to find sine, cosines, and tangents of everything, okay? Okay. What I want to do now is I'm going to hand out a very, very, very comprehensive little trifold with a bunch of angles that have already been predetermined for us, okay? This packet, this little trifold, is available at the tutoring center, and I'm going to put it in our notes once I have a chance to upload it, okay? And it's going to give us a bunch of the information from trig that we're going to need for the rest of calculus, okay? But the idea here is, one, I want to get a handle on sines, cosines, and tangents, right? But I also want to show you all how all of this stuff is derived, okay? And how this all connects to sine, cosines, and tangents, okay? Okay, so the first thing I got to do is define two triangles that you should remember from geometry in particular, right? One is isosceles triangle, and the other one is the equilateral triangle. So let me cover the isosceles triangle first. The isosceles triangle is the one where two sides and two angles are going to be equal. So if this and this are equal, then this angle and this angle have to be equal. This is the isosceles. Okay, and the equilateral is when everything is equal. So basically, all three angles are equal, that, and this side, this side, this side are equal. Okay, it just so happens that if you have this kind of equilateral triangle, all three of the angles are 60 degrees. Okay? Okay. Just with these two pieces of information, okay, we can derive the more important values from our unit circle, the values that are on the left-hand side of the screen. Okay? And that's what I'm about to do. So the first one I'm going to do is this one. I'm going to highlight the triangle. The first one I'm going to do is this one. This one's the 45 degrees. Okay? So I'm going to take that triangle out. I'm going to draw it separately right here. This is a right triangle, right? We know that this angle is 45 degrees. Since this angle is 90 degrees, right, we can automatically say that this other end is 45 degrees. Okay, since the two angles are equal, we have an an isosceles triangle. So that means this side and this side are the same. Okay, if you take a look at the circle that's on the right hand or on the left hand side of the screen, right, we're saying that this radius is equal to 1. Okay, so that means our hypotenuse here is equal to 1. I'm going to start calling stuff here. I'm going to say that this is A and this is A, since both of the sides are going to be the same size, right? So that means A squared plus A squared has to be equal to 1. 2A squared is equal to 1. A squared is equal to 1/2. So then A has got to be equal to the square root of 1/2. And if you do a bunch of arithmetic, you get that this is also equal to square root of 2/2. Okay? So that means both of these sides, the vertical and the horizontal component of a 45-degree triangle, they've got to be square root of 2/2. That is where those two values come from. Okay? The next one I want to do is the 60 degree, or sorry, the 30-degree triangle. So I'm going to get rid of this, and I'm going to highlight the 30-degree triangle, this one. Bam, bam, bam. Okay. I'm going to separate that triangle away. Right angle. So we know that this right here is 30 degrees. Okay. We know that this is 1. Right? That's our radius. Okay. There's something that we need to do before we start messing around with this triangle, and that is looking at an equilateral triangle. You guys remember the equilateral triangle that I was messing with just now, right? 60 degrees, 60 degrees, 60 degrees, okay? Since all three of these angles are the same, all three of these sides have to be the same. So that means each one of these is 1, 1, and 1, right? Okay. I can grab this triangle and slice it straight down the middle. Okay? Whoa. And it's going to zoom out. Of course it is. Okay? I can slice this triangle straight down the middle, and that makes each one of these angles, this one and this one, 30 degrees. Since I sliced the triangle in half, I automatically can say that this missing side over here, okay, that has to be 1/2 of 1, so 1/2. I need to find this missing side still. Okay, to do that, that's Pythagorean theorem. You guys see that? So I'm going to call that A again. A squared plus 1/2 squared is equal to 1 squared. Okay? A squared plus 1/4 is equal to 1. A squared is equal to 3/4 if you do the arithmetic right. So then A has got to be equal to the square root of 3/4. And if you do some more arithmetic, you get the square root of 3/2. So our new triangle here, I'm going to fill it in separately. Okay. If this is 1, we found out that this has got to be 1/2. This piece has got to be the square root of 3/2. Okay. And these are the 3 points that I really want to, this one and this one. Okay. The x component and the y component. Okay. This is how you construct these values using just sort of basic geometry. Okay. Now, the last triangle that I need to mess with, right, is this one. The 60-degree. But if you take a look, right, that is the previous triangle, the 30-degree triangle, sort of standing up. It's not on its side. Does that make sense? So that's where we get those values, but they're switched. Okay, so this one is taken care of just because we did the triangle for the 30-degree one. Okay, like I said, these are the more important angles and values that we're going to be playing around with when we talk about when we start messing around with trig in our calculus. Okay, anything else, we will have to compute stuff, and we'll pick up some more stuff from trig as we move along. Okay. Okay. And I believe that is it, huh? Yep, lecture questions comes up next. This might seem a little out of left field. I want everybody to get the practice with it. I know it's going to be quick. Like I said, the class is very dense. Give it your best shot and take your time with it, okay? If there's any questions with this, ask me during our quick check time, during our break, right? Or when I'm downstairs in the tutoring center, okay? Cool. Besides that, happy studying.